Right, so in this video I'm going to have a look at Leaving Cert higher level maths paper 1 2017. So in particular I'm going to have a look at question 8, which is a financial maths question. Now the first part of this question is to derive this amortization formula here. So we're told that when a loan of P euros is repaid in equal repayments of amount A euros at the end of each of T equal periods of time, when I is the periodic compound interest rate expressed as a decimal, this formula can be used to find the amount of each repayment. So we've got to derive this formula. So we're going to use the sum of a finite geometric series. So what does this formula mean? Well, it means if you take out a loan, to find out how much you have to repay at the end of each month or year or whatever time periods you're talking about, you just put in the values here into this formula here, and it'll give you your regular repayment amounts here, A. P is the loan amount, and I is the interest rate as a decimal, and T is the time period that you're talking about. Okay, so I've started it here, and let me just go down through what I've done so far. We'll have these time periods here. T0 here is now, T1 is 1 month later or 1 year later, whatever time period you're talking about in your particular case. So it could be 1 year later, 2 years later, and so on, T years later. Now we're going to use this formula here. F is equal to P times 1 plus I to the power of T. It's the final value is equal to the principal or the present value times 1 plus I times T. Rearranging this, we get P is equal to A over 1 plus I to the power of T. I just changed F to A here because that's what we're using in this question here. So just divide across by this part here. So you get P is equal to A over 1 plus I to the power of T. This gives you the present value of any future amount. Okay, so A here, as we go along, this is the amount you're going to pay on a regular basis. So at the end of year 1, for example, you would pay back an amount A. At the end of year 2, for example, you would also pay back the same amount A, and so on. At the end of 10 years or whatever it is, you'll still be paying back the same amount A. What we're going to do is find the present value of all of these amounts A algebraically, because you've got to remember that the loan amount is equal to the sum of all the present values of all future repayments. That statement is very important. The loan amount, the amount that you actually take out, is equal to the sum of the present values of all of these future repayments. So we're going to get the present values of all of these A's. So if you take the first one here, after 1 year, for example, or 1 month, you pay back A. But what's that worth now? Well, it's worth A over 1 plus I to the power of 1, because we're talking about 1 time period. What about after 2 time periods? Well, you're paying back the A again, another A. It's the same as this A. What's it worth now today? Well, it's worth A over 1 plus I squared, because we're talking about 2 time periods, and so on. If I had another line here, it would be A over 1 plus I cubed, because you'd be talking about 3 time periods, and so on. We're talking about T time periods, so I just did the last one here. What's this A amount worth today? Well, it's worth A over 1 plus I to the power of T, whatever T is. So if we add up all of these here, we'll get the loan amount P. So I've written that down here. P is equal to A over 1 plus I to the power of 1 plus A over 1 plus I to the power of 2 plus, and so on, all the way out here to A over 1 plus I to the power of T. Okay, so this is our geometric series here that we're going to use to derive this formula. So let's start. This is the sum of a geometric series here. You would know that from previous videos or different topics, but in our case we need to put in an A and an OR. Well, A is the first term in our series, and the first term is A over 1 plus I. So I've written that down here. OR is the common ratio, which is, what do I multiply this by to give me this? Well, just 1 over 1 plus I. That'll give me A over 1 plus I squared, and so on. So I have my A, I have my OR, put them into this formula, and let's manipulate it. So we're going to end up with P is equal to A, which is our first value, A over 1 plus I. Multiply that by 1 minus or 1 minus 1 over 1 plus I to the power of t, because our n in this case, our n is t. We have t time periods. So it's 1 to the power of t, which is just 1, and 1 plus I to the power of t, which is 1 plus I to the power of t, over 1 minus or. So it's 1 minus 1 over 1 plus I. Okay, so now we started. So I'm just going to multiply these two fractions, the top by the top. So if I multiply the top by the top, I'll get a times... Now, in fact, within this bracket, I'm going to add these two fractions. This is 1 over 1 minus 1 over 1 plus I to the power of t. So if I add those, I'll get 1 plus I to the power of t here as my common denominator. So 1 into this gives me 1 plus I to the power of t, times 1 is 1 plus I to the power of t, minus 1 plus I to the power of t into 1 plus I to the power of t is 1. 1 times 1 is 1. That's over. Now 1 plus I times 1 is 1 plus I. 1 plus I times minus 1 over 1 plus I is just 1. Multiply 1 plus I times this fraction here. This will end up on the top here, and you'll just divide 1 plus I by 1 plus I and you'll get 1. Okay, so just to simplify that out, then you can see here that we'll end up with I on the bottom here. You know, this 1 and this minus 1 here will just give me 0. So this I here will just end up here, in fact. So I'll end up here, P is equal to A times 1 plus I to the power of t minus 1 over I times 1 plus I to the power of t. Okay, so almost there. Now what I'm going to do here then is, I've got this a on its own on this side here, or sorry, not on its own, but I want to get it on its own. So I'm going to divide both sides by all of this here. Now this is a fraction, so if you divide by a fraction, I've got to flip it upside down and multiply it by p. So I'll just do it up here. So I'll end up with a is equal to p times I times 1 plus I to the power of t over 1 plus I to the power of t minus 1. And that is in fact what we want to end up with. I think in the question they have another bracket around here, but it's much the same thing. Okay, so all I did here at the very end was just divide by this fraction here. Divide both sides by this fraction, so I had to flip it upside down and multiply by p. And that's it. That's the derivation of that particular amortization formula. Okay, so let's have a look at the next part of this question. Let me just move this up a little bit, just to give me some room here. Now, Alex has a credit card debt of 5,000 euros. One method of clearing this debt is to make a fixed repayment at the end of each month. This repayment is 2.5% of the original debt. What is this fixed monthly repayment? So all we've got to do here, they're calling it A here as well, all you've got to do here is get 2.5% of 5,000. So that's just really 0.025 multiplied by 5,000 euros, and that gives you 125 euros. So he's got to pay back 125 euros at the end of each month. Okay, so let's have a look at the next question. Okay, so this is, let's see, the annual percentage rate, the APR. We talk about APR when we talk about loans. Charged on debt by the credit card company is 21.75%. Fixed for the term of the debt. Find as a percentage corrected 3 significant figures the monthly interest rate that is equivalent to an APR of 21.75%. So this is an annual rate here. We want to know what would be the equivalent monthly rate for this 21.75%. So what you can do here is you can say, we're going to use this formula here. F is equal to P times 1 plus I to the power of T. The final value is equal to the present value times 1 plus I to the power of T. Well, let's just take €1 and 1 plus I. We want to work out what I is. And our time periods now are going to be, we're talking about monthly, so it's going to be 12 months. 12 months. Now, what would happen to €1 over this 12 months at this percentage rate here? Well, its final value would be 1.2175. You can also use €100 here if that's easier. You can put €100 here, so you would end up with 121.75 euros. But I usually use 1. Okay, so now all we've got to do is work out what this I would be. Well, this thing here is raised to the power of 12, so we've got to get the 12th root of both sides. So in other words, that's going to be 1.2175 to the power of 1/12. And that's going to be equal to 1 plus I on this side. All we did was got the 12th root of both sides. I want to get I on its own here, so I here is just going to be this 1.2175 to the power of 1/12. And then we've got to subtract this 1 here from our answer. So what you'll find when you do this is just calculator work at this stage. You'll end up with I is equal to 0.016535. Now, it says find as a percentage. So this is not a percentage yet, so we've got to convert this to a percentage, and we've got to do it correct at 3 significant figures. The monthly interest rate. So our rate then, our monthly rate will be 1.65 to 3 significant figures. Remember, here's this is 1, 2, 3. This is 3 significant figures here. Because this is a 3 after the red line here, we just leave this 5 as 5. So it's 1.65%. This is our monthly rate. Right, let's have a look at the next part then. So we have a table here, and we're going to assume that Alex pays the fixed monthly repayment A each month and does not have any further transactions on his card. So he's going to pay back 125 euros per month. That's what we worked out in part 1. Complete the table below to show how the balance of the debt of 5,000 euros is reducing each month for the first 3 months, assuming an APR of 21.75%, so assuming an annual rate of 21.75%, charged and compounded monthly. Well, we know that this is actually 1.65% monthly, so we can use that here. So let's fill out the table. Well, we can see here that the balance here is 5,000 euros. This is how much money he has borrowed. So we know that he's going to pay back 125 euros. He's going to pay back 125 euros each month anyway. Now, the interest rate per month is 1.65%. So we've got to get 1.65% of this 5,000. Remember, they've already given us a few values here. So if we get this right, we can work it out and just make sure that these values are correct. Get 1.65% of 5,000 and you'll get 82.5. Now let's see, does that work out? Well, what you got to do is take 5,000, subtract 125 because that's how much he's paid back. But the interest is 82.5, so we got to add that on. He owes 82.5 euros in interest. So we take 5,000, subtract 125, add 82.5, and what you'll find is you do actually get 4957.5. So it does work out. the previous balance is reduced by this amount. In other words, subtract this amount here from 5,000 and you do get 42.5. So let's just continue that on then. So next thing, he pays back 125. This is how much he owes now, so you got to get 1.65% of this amount here, and that works out as, I'm not going to round these, but it's 81.79875. Now again, take this amount, subtract 125, add this amount because he owes it in interest, and you get 4914.29875. Again, I haven't rounded these. You can round them, but usually I leave rounding till the end if necessary. But they don't actually ask us to do any rounding here, so I'm not going to actually do any. So look, you subtract this from this again, and that'll give you how much it's reduced by. So it's when you subtract them, you get 43.20125. So you got to do the same thing again. Get 1.65% of this, and write our answer in here, and it's actually 81.0859293.8. So again, take this, subtract 125, add this, and you get 4870.384679. Okay, and then subtract these two here, and you get 43.9, 43.9, 14071. So that's it. You can see the amount of interest that he's actually paying back each month here, around 80 euros, 81, 82 euros. It's quite a lot every month to pay back in interest, given that he's paying back 125 euros as a regular repayment every month. Okay, so let's have a look at the next part. Using the formula you derived on the previous page or otherwise. So I'm going to use the formula. Find how long it would take to pay off a credit card debt of 5,000 euros using the repayment method outlined at the beginning of part B above. Give your answer in months correct to the nearest month. So how long is this going to take? Well, let's write down our formula first of all. Our formula is A is equal to P times I times 1 plus I to the power of T over 1 plus I to the power of T minus 1. Now we know that we're paying back 125 euros a month, so that's what our A is going to be, so 125 on this side. Principal is 5,000 euros, that's how much the loan amount is. Now let's fill out all of these other things here. So I is the interest rate as a decimal, so it's 0.0165. Here we got 1 plus 0.0165. That's the power of T. T is what we've got to work out. Give your answer in months. So this is what we've got to work out. Underneath here you've got 1 plus I, so that's 1.0165 to the power of T minus 1. Okay, so we've got to try and isolate. We have a T down here, we have a T up here, so we've got to work out what T is. First thing I'm going to do here is divide across by 5,000, because this 5,000 is multiplied by everything. And I'm also going to divide across by 0.0165, because that's multiplied by this fraction here as well, if you like. So I'm going to multiply, or divide across rather, by these two things here and multiply. So when you do that, you actually get 50 over 33. And that will leave me on the right hand side with 1.0165 to the power of T all over 1.0165 to the power of T minus 1. Right, so next thing I'm going to do is I'm just going to cross multiply here. I'm going to multiply across by 33, and I'm going to multiply across by this, but effectively I'm going to cross multiply the top by the bottom, bottom by the top, because I have a fraction equal to a fraction. So what I end up with here is 50 times 1.0165 to the power of t minus, so I've multiplied 50 by this, I'm going to multiply 50 by this minus 1, so that gives me minus 50. That's going to be equal to 33 times the top here, so it's 33 times, this is not a decimal point, this is not a decimal point, this means multiply, 33 times 1.0165 to the power of t. Okay, so next thing I'm going to do then is, look, I've got 50 of these here, 1.0165 t's, and I've got 33 of them on this side. So what I'm going to do is I'm going to bring this over here and subtract. So I've got 50 of these minus 33 of these. That gives me 17 multiplied by 1.0165 t's. I'm going to take this minus 50 and bring it over here, so I end up with 50 on this side. Now, next thing I'm going to do is I'm going to divide across by 17. I'm going to move up here now, so I end up with 1.0165 t is equal to 50 divided by 17. Right, now we've got a variable as our power here, so I'm going to get the log of both sides. I'm going to use the natural log, so I'm going to use natural log of 1.0165 to the power of t equals log 50 over 17. Now again, using one of the laws of logs, I'm going to take this t here and bring it down here. So I'll end up with t times the log 1.0165 is equal to the log of 50 over 17. Last thing I'm going to do then is just isolate this t. This t is multiplied by this log here, so I'm going to take log 50 over 17 divide by log 1.0165. When you do that, you can just do that on your calculator, you get 65.92. 65.92. So the question again was, find out how long it would take to pay off the credit card debt of €5,000 using the repayment method outlined at the beginning of part B above. So it will take 65.92 months, or 66 months to round, if I were to round it up here. So 66 months. Okay, so let's look at the next question then. Now, in this particular case, Alex decides to borrow €5,000 from a local credit union to pay off his credit card debt. The APR charge for the credit union is 8.5%. So you can see the interest rate is a lot lower than for a credit card. So it's a good idea to take out this loan, because he's going to have to pay back less to the credit union than he will to the credit card company. So it's fixed term. Okay, so the loan is to be repaid in equal weekly repayments, this time at the end of each week for 156 weeks. Find the amount of each weekly repayment. Now there are two ways of doing this. You can do this using the sum of a geometric series, or you can use the amortization formula. You get the same answer either way. So for example, if we were to use the time, the geometric series, the time periods method, so you're looking at, say, T0, T1, T2, and so on, and then you've got up as far as 156 here. So this would be the first week, the second week, third week, fourth week, up to 156 weeks. So we first of all know that the interest rate here is an APR, it's an annual rate. So what we've got to do is, because we're talking about weekly here now, we've got to convert this as well to a weekly we've got to work out what this weekly rate would be. So let me just do that quickly first. So we've done this previously in a previous part of the question. It's the same kind of procedure. So let's see, we've got the final value is equal to p times 1 plus I to the power of t. Now again, if you were to take, let's say, €1 here, 1 plus I is what we got to work out, and now we're talking about 52 weeks in a year, so we put 52 here. So this €1 would turn into 1.085 euros in 1 year. So you got to work out what this I would be. So again, we would need to get 1.085. We've got to raise that to the power of 1 over 52. So we get the 52nd root of this number. We got to subtract this 1, and that will give us I here. So when you do that, you will get an interest rate of, or an I of 0.00157 007 186. Okay, so if you were to get the present values then of all of these amounts, similar to what we did in part A here, so if we take this amount here, get the present value of it, you would be looking at A over 1.00157. Now I'm not going to keep writing out this entire number all the time, so but in the calculations I will actually use it. So that's just going to be to the power of 1. If we take this one here, that's going to be A over 1.00157 and so on squared, and if we take the last one, go right back to the start, get the present value of that one, it's going to be A over 1.00157 to the power of 156. Add all of those up, it should add up to 5,000 euros. So again, very similar to what we did in the first question. We know that 5,000 euros is going to be equal to A over 1.00157 to the power of 1 plus A over 1.00157 to the power of 2 plus, and so on, plus out to the end A over 1.00157 to the power of 156. Now this again is a geometric series with A here is equal to well, actually what I'm going to do here, just to make it a little bit easier, is I'm going to factorize out the A. So you factorize out the A here, you'll end up with A into 1 over 1.00157 plus 1 over 1.00157 to the power of 2 plus, and so on. Now our A here in this case is actually going to be 1 over 1.00157. Again, I've kind of rounded this, but in the calculations when I do the answer, I've actually used this entire number here. So let's have a look then. A is equal to that, and then my OR here is going to be equal to, well, it's just going to be the same thing again. It's going to be 1 over 1.00157 again, because that's what you got to multiply each of these by to get the next term. So after that, then you just got to do the calculation. So you got 5,000 here, you got equal to A over, or A times rather, remember the formula here is Sn is equal to A times 1 minus R to the power of n over 1 minus R. So A is 1 over 1.00157 times 1 minus, or 1 over 1.00157 to the power of n, in this case is 156, and all of that is over 1 minus 4. and the R here again is 1 over 1.00157. So this is the calculation that you've got to do. Look, I'll let you do that yourselves. There's a little bit of fiddling about here, but you can do that on your calculators yourselves. And what you'll end up with here is 5,000 is equal to A times 138.2683542. Again, remember I didn't use this number, I used the extended version of this number. Now divide across then and you'll get A is equal to divide by 138.268 and so on, and you'll get 36.16. So this is the amount that you'll have to pay back the credit union each week. Now, as I say, you can do this easy. The easy way of doing it is just use the amortization formula. So just to quickly do that, let's put a line here. So the amortization formula again is just A is equal to P times I times 1 plus I to the power of T all over 1 plus I to the power of T minus 1. So again, this works out. We should end up, if we do everything on the right hand side here, we should end up with 36.16. So it's just going to be A is equal to, P is 5,000. Now the interest rate here is 0.00157. Again, use the longer version of that. 1.00157 to the power of 156 all over 1.00157 to the power of 156 minus 1. So this is a quicker way of doing it really. And look, when you do all of this, again, these are all just numbers. You can type all of this, or at least do it in a few steps maybe in between, just to be sure you don't type something wrong into your calculator. You do actually end up with 36.16 euros as well. So that's that part of the question done. So let's have a look at part of VI here. Maybe I'll just move this up a little bit. Okay, so this is, let's see, how much will Alex save by paying off the credit card debt using the loan from the credit union instead of paying off the fixed repayment from part B1 each month to the credit card company? So you can see that the credit card company's interest rate is a lot higher than the credit union's interest rate. So let's just work it out. We know from the beginning of this question that he had to pay 125 euros off each month, and then we worked out in part IV of B that it would take 66 months to pay this off. So you got to multiply this by 66. That gives you 8,250 euros. So in other words, he took out a loan of 5,000 euros. This is the amount he actually pays back to the not to the credit union, to the credit card company. Now, if he took out a loan from the credit union to pay off the credit card debt and then just paid off the credit union instead of the credit card company, he would pay back 36 euros and 16 cents, and he pays that off for 156 weeks. So he's got to pay this back for 156 weeks. So if we multiply this out, he actually pays back 5,640 euros and 96 cents. So he saved quite a bit here. So if you just subtract these two, 8250 minus 5640.96, there's a difference of 2,609 and 4 cents. So this is how much he will actually save by taking out a loan from the credit union and paying off the credit card company, and just paying back the credit union then on a weekly basis. Okay, so that was quite a long question, but that's it for question 8.